Okay, now we're going to talk about a different kind of angle. Remember our central angles last time had the center at the center of the circle. This one does not have it at the center of the circle. Its vertex is at the edge of the circle. It's sitting on the circle here. So this is called an inscribed angle. Where its vertex is on the circle. We still call this an intercepted arc on here. It's this part of the arc that is inside the angle we're talking about. And the measure of the inscribed angle is always half of the measure of the arc. So whatever this angle is here, it's half of this arc out here. So if we look at here, we're going to write up some little formulas. The angle ADC is half the arc AC, and that means that the arc here is 2 times the angle. So the angle is half the arc, and the arc is 2 times the angle. So now we're going to work some problems with these, and we should be able to go both ways. Remember, the angle is half the arc. The angle is half the arc. So if this is half the arc, that means I need to multiply times 2 to get the arc. The arc is 90. The angle is half the arc. Now here they gave me the arc, and the angle needs to be half of this, so I divide by 2 here to get this is 38. Notice on this next one, here's the arc, and then there's 2 angles there. Here's my first one, the blue one. This blue one is going to be half this arc, so I divide by 2 and I find that this blue one is 62. Then there's also this other angle here, this red one, and it goes to the same arc. So this one's going to also be half of that one, so it's going to be 62. So both of those are 62. Okay, this next one, notice that this right here is a half of the circle. So what is this arc on this side? Well, that's 180. Half of this is this angle here, which makes this one 90 degrees. Then if I look at this angle, it goes to this 60 here. Well, what is half of that? Well, half of that makes this one 30 degrees. So I can finish doing this 2 ways. One, I know all the way around the outside adds up to 360. So I can do 180 plus 60 equals 240. Subtract from 360, and I get that this side is 120. And that means this angle here is half of that, so this angle here is 60. Or, what do you know about the angles inside a triangle? They add up to 180. Do these add up to 180? They do. So I could have also found this one by knowing that those 3 add up to 180. So all of this is coming back around, and everything we've done this year, you're kind of seeing some of it come back, like the angles in a triangle add up to 180. All right, our next one here, notice a couple of things. One, this goes right through the middle, so I know that this is half the circle on each side. But this arc right here is not inside the angle there. So this angle is not half of that one. This angle here is half of this side on this part right here. So how am I going to find this part? Well, we said this side is 180. So this whole side is 180. So I'm finding this blue arc by doing 180 minus 56. And I get 124. And then divide, so this is 124, then divide that by 2 to get this angle here, which makes this 62 degrees. Alright, on here you have to look carefully, and it may help you if you need a colored pencil to kind of draw in some of these arcs and stuff like I am. Just come ask and I'll be happy to give you colored pencils. So let's see, this angle right here that's 45, that goes with this part here. So if this is 45, it's half of this arc, so this arc is 90. And now if I look at this other one, this angle here is half of this same arc. So x happens to be 45 because it's half of 90. But I also need to find this y on this side. If I look at this angle going this way, this 40 is half of this arc on this side. So that means that this side is 80 because 40 is half of 80. And then that means that this angle here goes to the same arc on that side, so that makes y 40 because 40 is half of 80. And finally we have this picture that has a central angle and an inscribed angle in it. If I start with the inscribed angle is 50, and that means this arc on this side has to be 100 because the angle is half the arc. Well, then I remember from last time that if I look at the central angle is equal to the arc, so that makes the central angle be 100.